Something extraordinary is happening in the night sky. Somewhere out there, far beyond the orbits of the familiar planets, an object has entered our solar system. It isn't from here. It doesn't belong to the sun. And unlike the planets, asteroids, or comets we've cataloged by the millions, this visitor is passing through on a one-way journey. Once it departs, it will never return. Astronomers call it 3I Atlas, and its arrival is a rare and historic event. To appreciate just how remarkable this is, let's pause and consider perspective. Humanity has been gazing at the sky for millennia. We've mapped stars, charted comets, tracked asteroids, and even sent spacecraft out into interstellar space. Yet in all this time, we've only ever identified 3 objects from outside our solar system, making a confirmed pass through our neighborhood. 3 in all of history. The first, back in 2017, was the enigmatic Oumuamua, the cigar-shaped rock that sparked debates about whether it was natural or artificial. 2 years later, in 2019, came Comet Borisov, which looked more like a traditional comet, but still carried the unmistakable signature of interstellar origin. And now, in 2025, we welcome the third, 3I Atlas. Its official name encodes this history. The 3I means third interstellar object, and Atlas credits the survey that first caught sight of it. What makes 3I Atlas especially compelling is that it is not a faint, fleeting speck on the edge of detectability. It is large, far larger than Oumuamua and even bigger than Borisov. Early measurements suggest it could be between 5 and 11 kilometers across, making it a true colossus among known interstellar objects. Unlike its predecessors, this one will stay bright and observable for many months, giving scientists a rare and precious window to study it in detail. Think of the improbability here. Our solar system is vast, tens of billions of kilometers wide. Space itself is empty or still, with stars separated by light years of distance. The odds that a solid fragment, cast off during the birth of another star system billions of years ago, would travel across the galaxy, wander into our celestial neighborhood, and be noticed by human instruments. Those odds are almost incalculably small. Yet here it is, streaking across our sky. In many ways, 3I Atlas forces us to reconsider just how dynamic the galaxy is. A galaxy in which stars and their worlds are constantly exchanging fragments, and where the story of our origins is still being written, sometimes in the form of strangers drifting silently through the dark. And with 3I Atlas, humanity has just been handed another page of that story. For all the grandeur of deep space, sometimes history begins with a small dot of light. That was the case in early 2025. ATLAS, short for Asteroid Terrestrial Impact Last Alert System, was not designed to look for alien visitors. Its mission is to protect Earth by spotting asteroids and comets that might be on a collision course with our planet. In a way, it is our cosmic watchtower, quietly keeping vigil every night. But what ATLAS found was not a threat. It was something far stranger. The system flagged a faint, fast-moving point of light. At first glance, it looked like countless other small bodies cataloged by the survey. Yet, the more astronomers tracked its motion, the more it refused to behave like a normal comet. Its trajectory was too sharp, too steep, and above all, too fast. It wasn't looping gracefully around the sun in an ellipse like everything else born in our solar system. Instead, it was cutting across space on a hyperbolic path, a trajectory that meant it had come from beyond the sun's grasp and was destined to leave again forever. When the orbital math confirmed this, astronomers knew what they had: an interstellar object, the third ever. The discovery sparked excitement because astronomers knew how rare this opportunity would be. Oumuamua, the first of its kind, had appeared suddenly in 2017 and vanished just as quickly, slipping out of view before telescopes could truly capture its secrets. Borisov, the second, was more cooperative, giving us glimpses of a comet that looked more familiar, though still alien in subtle ways. But 3I Atlas promised something different. It was brighter, larger, and entering on a path that would keep it visible for many months. Unlike the fleeting mysteries of the past, this one offered time. Time to plan observations, time to aim the most powerful instruments on Earth and in space, and time to gather data. And so the stage was set. Humanity had found its third interstellar visitor. The question now was, what secrets would it reveal? When astronomers first began to measure 3I Atlas, one detail stood out almost immediately. This was no small, fragile shard of cosmic ice. Early estimates put its size somewhere between 5 and 11 kilometers across. By sheer scale alone, 3I Atlas dwarfs its predecessors. Oumuamua, the mysterious first interstellar object discovered in 2017, was barely a few hundred meters long, a speck compared to Atlas. Borisov, discovered in 2019, stretched about a kilometer or so across, resembling a fairly typical comet. But this new visitor? It is potentially 10 times larger. For astronomers, this was a stroke of fortune. A bigger object means it reflects more sunlight, making it easier to observe over long distances and longer periods of time. It also means a more robust body that is less likely to break apart or fade too quickly. In short, this was an interstellar object built to endure and built to be studied. Then there is the matter of its orbit. The defining trait of an interstellar object is that it does not move in the gentle closed ellipses that describe the orbits of planets and comets native to our solar system. Instead, it follows a hyperbolic path, an open curve that ensures it will enter once, swing around the sun, and then vanish back into interstellar space forever. The mathematics of its orbit leave no room for doubt. 3I Atlas was not born here. It is a foreigner, a wanderer from the galactic sea. It will loop briefly inside Mars's orbit, grazing the warmth of our star, before being flung outward again, never to return. And that one passage, a fleeting cosmic visit, lasting scarcely more than a year, is all the time humanity has to learn from it. It is tempting to think of 3I Atlas as a kind of ambassador. Its size makes it an especially valuable one. Larger bodies preserve their internal chemistry better than smaller, more fragile fragments, which can be eroded by cosmic rays or vaporized by starward journeys. This means that within 3I Atlas lies the potential to hold uncorrupted material from another planetary nursery, a sample of cosmic history untouched for billions of years. If the sheer size and alien trajectory of 3I Atlas weren't enough to captivate astronomers, its chemistry sealed its reputation as one of the most intriguing objects ever seen. Within weeks of its discovery, scientists pointed the James Webb Space Telescope toward the newcomer. What Webb found in the spectrum of 3I Atlas was something no one expected. Most comets in our solar system are a mixture of water ice, carbon dioxide, dust, and other frozen compounds. The ratios vary, but there is usually a balance. Water dominates, with carbon dioxide and carbon monoxide present in smaller amounts. But 3I Atlas broke the rules. Its carbon dioxide to water ratio was measured at 8:1, meaning for every molecule of water, there were 8 molecules of CO2. That is not just unusual, it is extreme. In fact, it is one of the highest ratios ever recorded for any comet, solar system, or otherwise. The finding left scientists scrambling for explanations. Why would a comet have such a skewed chemistry? One possibility is that 3I Atlas formed in an environment of extreme cold. At very low temperatures, water freezes so hard into rocky grains that it becomes difficult to incorporate into larger icy bodies, while carbon dioxide remains more volatile and abundant. Another possibility is that this comet was once exposed to intense cosmic radiation. Over millions or even billions of years, radiation can break down water molecules and drive them off into space, leaving carbon dioxide behind. This is the beauty of interstellar visitors. They are snapshots of alien environments. When we look at 3I Atlas, we are not just studying a comet, we are peering into the early chemistry of a planetary system we may never otherwise see. The strange dominance of carbon dioxide hints that planetary nurseries across the galaxy may be far more diverse than we once imagined. Some may form around cooler stars where radiation shapes chemistry differently. Others may exist in outer regions of star systems where water is scarce, but carbon dioxide-rich ices are plentiful. Each scenario broadens our understanding of what normal can mean in the cosmos. The implications ripple outward. For decades, astrobiology has worked under the assumption that water is the universal ingredient of life, the solvent that must exist for biology to emerge. But what if other planetary systems produce bodies where water is limited and carbon dioxide dominates? Could this alter the chemistry of atmospheres, oceans, or even potential biology in those systems? While 3I Atlas itself is almost certainly lifeless, its composition forces us to imagine a wider range of possibilities for worlds beyond our sun. What astonished scientists further was how clearly Webb's instruments picked up these signatures. Unlike Oumuamua, which never displayed a clear coma of gas or dust, and unlike Borisov, which resembled a fairly ordinary comet, 3I Atlas provided rich, unambiguous chemical fingerprints. This makes it the most revealing interstellar object to date, a kind of open book compared to the cryptic glimpses of its predecessors. As the months pass and the comet swings closer to the sun, astronomers expect its activity to increase, releasing more gas and dust, and giving telescopes an even better look at its internal makeup. Each observation adds another brushstroke to the picture of its origins. Will it confirm the radiation theory? Will it show exotic compounds never before seen in comets? Or will it present a hybrid scenario no one has yet considered? On October 29, 2025, 3I Atlas will make its closest approach to the sun. It will not dive perilously near, like some sun-grazing comets that skim just above the solar surface. Instead, its path takes it to a respectful distance, just inside the orbit of Mars. From there, it will loop around and begin its long journey outward again. To the naked eye, most people on Earth may never notice it. This will not be a comet blazing across the sky with a spectacular tail like Halley's or Hale-Bopp. But for telescopes, from the giant ground-based observatories to orbiting instruments like Webb and Hubble, it will be a perfect target. Bright enough, large enough, and present long enough to become a laboratory in motion. The extended window of visibility is crucial. Astronomers expect that 3I Atlas will remain observable until mid-2026. That gives nearly a year and a half of time to track how its activity changes as it approaches and then retreats from the sun. In our own solar system, comets behave almost like living things. Their frozen surfaces wake up as they are warmed, jets of gas erupt, and dust tails blossom. Scientists want to see whether 3I Atlas follows the same script, or whether its alien chemistry writes a different story altogether. Tracking its motion also allows astronomers to refine its orbit with incredible precision. Already, the data confirm that its speed is too high for it to be bound by the sun's gravity. Long after it rounds its closest approach, it will keep climbing away, eventually vanishing back into the interstellar sea. In fact, millions of years from now, it may wander into another star system entirely, where distant descendants of intelligent beings might detect it and wonder, just as we do now, about the worlds it once called home. For Earth, though, this flyby is a once-in-history event. No telescope will see it again once it departs. That sense of impermanence hangs over every observation. Oumuamua was here and gone in a matter of weeks, leaving behind only unanswered questions. Borisov lasted longer, but was too small and faint to provide much clarity. 3I Atlas is different. It is bright, massive, and cooperative. Almost as if the galaxy is finally giving us the interstellar object we've been waiting for. A chance to study in depth what the other two only hinted at. The natural question is this: are they related? Could it be that Oumuamua, Borisov, and Atlas were all cast out from the same stellar nursery, fragments of a single disrupted system, wandering separately through the galaxy until, by astonishing coincidence, each happened to pass through our solar system within a single human lifetime? If so, then we are not just catching glimpses of strangers. We are tracing the diaspora of an ancient family of objects, shards from a long-lost world. Astronomers tread carefully with such ideas, but the possibility is not unthinkable. The galaxy is vast, yet stars are not scattered randomly. They are born in clusters, and for millions of years after their birth, the gravity of nearby stars continues to shape their planetary systems. Many comets and planetesimals are ejected in these early chaotic eras, flung into interstellar space like seeds carried on the wind. If a cluster expelled trillions of such bodies, they would fan out across the galaxy, traveling in roughly similar directions for tens or even hundreds of millions of years before dispersing entirely. Perhaps Oumuamua, Borisov, and Atlas are three such seeds, remnants of a stellar nursery that once thrived in some corner of the Milky Way. Perhaps they carry with them a fingerprint of that place, a shared chemistry, a shared history, written in their ices. If spectroscopy shows similarities in their molecular makeup, it might point to a common neighborhood of origin, not proof, but a tantalizing clue. Or perhaps the opposite is true. Perhaps their diversity is the message. Oumuamua with its dry, inactive surface, Borisov with its comet-like coma, Atlas with its brightness and scale. Three travelers, three different stories, reminding us that planetary systems, like people, are not uniform. Each star scatters its own fragments, and the fact that we have seen three in less than a decade is not coincidence but revelation. For humanity, that is more than scientific trivia. It is a shift in perspective. It means we are not isolated. Other worlds do not just exist in theory. Their fragments sweep through our skies. Every interstellar object we study deepens our understanding of how common planetary systems are, how they evolve, and what chemistry might be universal across the stars. And it plants another thought, a poetic one. If debris from other systems can come to us, then debris from ours must also travel outward. Somewhere, perhaps, another civilization is watching a faint comet in its night sky, measuring its spectrum, wondering where it came from. They may not know it, but they could be studying a fragment of our home. 3I Atlas matters because it closes the gap between imagination and evidence. For centuries, we dreamed of other worlds, but had no proof. Now, in less than 10 years, we have held 3 in our telescopes, each one a messenger from beyond. Whether they are siblings or strangers, they remind us of the same truth. The galaxy is alive with motion, exchange, and connection. We are not at the center of it, but a participant in it. And as 3I Atlas makes its brief passage through our skies, it offers us a choice: to look up, to wonder, and to take seriously the idea that the universe is closer, more intimate, and more intertwined than we ever imagined. This is AstroTheatis. Stay curious and keep looking up.